Alright, you guys, so we are back with Unit 3 for the midterm review. We're going to start talking about some lines here. The first section is asking to state whether or not the lines are parallel, skew, or perpendicular. If the lines are parallel, then you know that the lines are on the same plane and they're never going to touch. They're going in the same direction. If your lines are skew, then you know that they are on two separate planes and they're never going to touch. And then if your lines are perpendicular, then you know they intersect at a 90-degree angle. Number 1 is asking for WZ and XY. Those lines are going the same direction on the same plane. They're never going to touch, so that is called parallel. Problem number 3 is asking for SY, this one right here, and WX, this one right here. Those are on two separate planes. They're never going to touch, but they're not parallel. They are what we call skew. The next section is asking about angles, specifically the corresponding alternate interior, alternate exterior, consecutive interior, or no relationship. So what we're going to do is just talk about these definitions real quick. Corresponding, I like to say they are in the same spot. Alternate interior, those are on opposite sides of the transversal on the inside of the two lines. Alternate exterior are on opposite sides of that transversal and on the outside of your two lines. Consecutive or same side interior is another word for inside. So you're looking for same side inside. My first angles that I'm going to look at is 1 and 9, here and here. I'm going to cover up this section. I'm not looking at that piece. I'm just looking at this one transversal and these two lines. When I look at just this one transversal, I know that angle 1 is in the top left-hand corner of these four angles. When I go down to the bottom, angle 9 is in the top left-hand corner of these four angles. So what we say is those are in the same spot, or those are corresponding angles. Number 7 is angle 6 and angle 16. So right here and right here. So I'm going to cover up this transversal because I'm not talking about that one. And I'll look at this transversal. Angle 6 and angle 16 are on opposite sides of that transversal, and they're on the outside of these two lines. So what we call opposite outside is alternate exterior. Number 9 is asking for angle 8 and angle 16. So I'm looking at this transversal again. I cover up this one, and I notice 8 and 16 are in the same spot, so those are called corresponding. Number 11, angle 3 and angle 13. Notice they are on two separate transversals, so they're going to have no relationship. Okay, next section. If we know our lines are parallel, then we know something about our angles. It tells me M and N are parallel. So what I know about these two corresponding angles is that they are congruent. They are equal to each other. If you don't have that memorized, you're going to need to go back and review those relationships, because you have to be able to look at those angles, know they're corresponding, and then know what that means. Okay? All of your angle relationships are going to be congruent except for consecutive interior, which would be this one and this one. Those are going to be supplementary. So that's one way you can remember it. If I'm going to solve for x here, I'm going to divide by 8, you get x equals 16. notice number 15 is that relationship we were just talking about. The exception, it's the consecutive interior relationship. They're on the same side inside angles, so they're not equal to each other, but what we do know is that they add to equal 180. So I'm going to set up an equation, 2x plus 36 plus that 4x equals 180. Combine your like terms. 4x plus 2x is 6x plus 36 equals 180. Subtract your 36 from both sides. You get 144. 6x equals 144. From there, you would divide by 6, divide by 6. So x is going to equal 144 divided by 6, 24. Moving on, we're going to do a little algebra review here. It's asking us to find the slope of lines that pass through the given point. My slope equation, which you need to have memorized, is m is equal to y2 minus y1 over x2 minus x1. The change in y over the change in x. So I label my points x1, y1, x2, y2, and I subtract y2 minus y1 over x2 minus x1. 7 minus 2 is 5 over 7 minus 1 is 6. So this is the slope of the line that goes through those 2 points. Remember, this means rise 5 over run 6. You can do that same thing for number 19. y2, which is 8, minus y1, which is a negative 2. Notice that minus a negative, it always turns into plus a positive. And then over the change in x, 5 minus 5. 8 plus 2 is 10. 5 minus 5 is 0. If you tried to plug this into your calculator, 10 divided by 0, you're going to get an error message. That's because this slope is undefined. Moving on, identifying slope when you're given an equation. You know that if you have the equation where y is by itself, y equals mx plus b, that the m, or the number right next to the x, is always your slope. So what you'll want to do is get each one of these into slope-intercept form so you can identify the slope. Here, my y is by itself, so it says y equals, but notice the m is actually right next to the x over here. So the 5 is your y-intercept, and the negative 3 is your slope, because it's the number right next to the x. Number 23 is actually in point slope form. Point slope form also is able to identify your slope by looking right here. But if I wanted to get it into slope-intercept form, I could do that just by simplifying and reducing. 3x minus 6 equals that y minus 5. You would add 5 to both sides. Y equals 3x minus 1. So again, you see the slope right here. That number right next to the x, which is going to be 3. So number 23, your slope is 3. Number 21, your slope is negative 3. Number 25 is identify the slope that is perpendicular to the line given. If parallel lines have the same slope, then perpendicular are going to have the exact opposite slope. And what you know about an opposite slope is you're going to need to flip the fraction and change the sign. So if you start with a positive slope, then your perpendicular slope is going to be negative. If you start with a negative slope, then your perpendicular slope is going to be positive. So like I did in the first few problems, I want to go back and make this into y-intercept form so I can identify my slope. So in order to move these x's to the right, I'm going to subtract them, cancel them out over there, and then rewrite my equation. I've got negative y equals negative 3x plus 8. From there, my y needs to be by itself, and right now it has that negative 1 right next to it. So I'm going to divide by a negative 1 in order to cancel it. Divide each piece by a -1, and you'll get y equals 3x minus 8. From here, I can identify my slope is 3. So if I was going to look for a parallel line, then I would keep the slope the same. But I don't want parallel. I want perpendicular. And so what I'm going to do is instead of 3 over 1, I'm going to flip that fraction. So it'll be 1 over 3 and change the sign. Here it's positive, so my perpendicular slope is going to be negative. This is my perpendicular slope to a positive 3. Flip the fraction and change the sign. Continuing with a little algebra review, we're asking which lines are parallel and which are perpendicular. Again, in order to identify your slope, it has to say y equals mx plus b, where the number right next to the x is your slope. So line A has a slope of 6, line B has a slope of negative 1/6, and line C has a slope of negative 6. First thing I want to do is look to see if any of them are parallel, because that's the easiest. Parallel means my slopes are exactly the same. Are any of these numbers 6, negative 1/6, or negative 6 the exact same? No. So I know it's not parallel. Then I want to look for perpendicular. I want to see which one has the opposite reciprocal of another slope. So exactly opposite. Flip the fraction and change the sign. Here's a fraction, so I know I've got negative 1/6. If I was going to flip that fraction, it'd be 6 over 1, and change the sign would be positive. So I know this positive 6 over 1 right here is going to be perpendicular to this negative 1/6. So line A and B are perpendicular. Moving on to number 29, it says write an equation of the line that passes through the given point. If I'm going to write an equation, the first thing I need is my slope. So I need to do y2 minus y1 over x2 minus x1. y2 is a negative 2 minus y1 is 0 over x2, which is 0, minus x1, which is a negative 1. I know that minus a negative turns into plus a positive, so you get negative 2 over 1 for your slope, which is the same thing as a negative 2. Now what you want to do here is plug it into point slope formula, and I'm going to go ahead and show you that, even though there is a little shortcut here because I do already have my y-intercept. So I'm going to go ahead and work it the longer way so you can learn how to work these out. Once you have your slope and you have a point, you want to plug it into point slope form. It doesn't matter which point you choose. I'm just going to choose this one. So from here, I take my slope and I plug it into y minus y1 equals m times x minus x1. This is what we call point slope formula. When you have a point and you have a slope, you always want to plug it into here. The y stays the same, and then your y1 is a negative 2. Then you plug in your slope. My slope is a negative 2. That's what I found first. Times x minus x1. x1 is 0. So from here, I'm just going to simplify, distribute. Negative 2 times x is a negative 2x. Negative 2 times 0 is just 0. So you've got y minus 2 equals a negative 2x. Then from here, you would add 2. I made a mistake. Minus a negative 2 turns into plus a positive. So from here, you would subtract 2. I apologize. So you subtract 2 on both sides, and it cancels. And your equation becomes y equals a negative 2x minus 2. You know that you've written the equation for a line when it's in slope-intercept form, where this is your slope and this is your y-intercept. Number 33 and 35, you're just finding the angle measures using vertical angles, using supplementary angles, complementary angles, things like that. I'm going to go ahead and solve the whole thing, even though I've got 33 and 35 circled. The first thing I notice is that angle 1 is 90 degrees. and angle 5 and 3 are complementary. I also noticed the angle 60 degrees right there is vertical angles with angle 3, so this would be 60. Since angle 3 is 60 and angle 3 plus angle 5 is 90, then angle 5 is going to be 30. I just took 90 minus 60. Since angle 5 is 30 and angle 1 is 90, I know that angle 1 is directly opposite or vertical to angle 5 and 6. So 5 and 6 are also going to be complementary, which makes angle 6 60 degrees. Angle 2 and angle 60 are also complementary because this line right here and this line right here are perpendicular. When they are perpendicular, then that means that your other two angles are also complementary. So that 60 plus angle 2 has to equal 90, so angle 2 is also going to be 30. Angle 2 is directly opposite or vertical to angle 4, so angle 4 is also 30. So 1 is 90, 2 is 30, 3 is 60, 4 is 30, 5 is 60. Oh, excuse me, 6 is 60. Okay? Last problems for this unit are a little bit of a review. You're just graphing the equation. Remember from writing equations in slope-intercept form, you always want to get that y by itself. It's where it says y equals mx plus b. That's how you graph a line. You would start at the y-intercept right here, and then you would use your slope to tell you the direction that you need to go in. In order to graph a line, you have to get it into this form. So here, in order to get y by itself, I need to move my x to the right. I'm going to subtract it in order to cancel and move it over here. I'm going to rewrite my equation. Y equals that negative x plus 14. So what that tells me is that my slope is a negative 1 and my y-intercept is 14. So I start at the y-intercept, I go up to 14. Notice they are counting by 4s, so 14 is going to be right here in the middle of 12 and 16. Then I want to go down 1, right 1. Because it's counting by 4s, it's going to be a little bit crazy, but what I'll do is I'll just go down 1 block over 1 block. So that's the same thing as going down 4, right 4, which is the same thing as down 1 over 1. And this would be your line. Number 39, I want to do the same thing. I want to get it into slope-intercept form in order to graph. So the first thing I want to do is move my x's to the right. So I'm going to add 4x to cancel, and whatever you do to one side, you have to do to the other. So I'm going to rewrite my equation down here. I have 2y equals 4x plus 10 left. My y is still not by itself, so I need to divide by 2, divide by 2, divide by 2. So you get y equals 2x plus 5. Notice the y is by itself, so I know that this is my y-intercept, where I'm going to start, and then this is my direction or slope that I'm going to go in. 5, notice they're counting by 2s, so that's 2, 4, 5 is where I start. And then I want to go up 2 over 1. Up 2 over 1. So up 2 over 1. And that would be right in the middle of that square. Up 2 over 1. Okay, if I wanted to work backwards, I would go down 2 over 1. Down 2 over 1. And that'll be your line. Probably one of the biggest mistakes people do is when they are using slope, they mess up with going right or left. Always go right 1, and then, or right when you're running, rise over run. Always run right, unless you're working backwards, and then you can run backwards left. But if you stay consistent going right, then you'll get that slope right. Alright? Well, that's the end of Unit 3 review. I've done all the odds for you, some of the evens, so hopefully that'll help you guys out.